Hello, I'm Stewart Hopper. I am in the MEMT 201 Section 1 Engineering Materials class. Today, I will be discussing a common material used in commercial aircraft use and its heat treatments. To understand materials used in aircraft, we must first examine the history of airplanes. This began when the Wright brothers took off in the first ever airplane in 1903. They flew a total of 852 feet within a time of 59 seconds. Since then, airplanes have been evolving into the futuristic flying machines we see today. Airplanes are utilized in a variety of settings, ranging from military use, commercial use, and even personal use. Their ability to cover vast distances in short amounts of time and carry heavy payloads makes them the method of choice for many companies and individuals. When looking at early aircraft, it can be noted that they were constructed of wood and fabric. This material was abundant, and it was the only combination of materials light enough to be lifted by the engines they had available back in the day. However, this made them dangerous. Should the plane experience a rough landing, the aircraft could potentially be subject to a major failure and possibly catch fire. This, for obvious reasons, would be detrimental to the passengers and the payload. However, as the means to power the aircraft improved, so too did the aircraft themselves. Despite its use, an airplane will experience a tremendous amount of stress. This means the materials used must be strong enough to withstand these stresses. These stresses will also vary when in flight, on the ground, with the speed at which the aircraft is traveling, and the weight of the cargo on the plane. Today, the material I will be focusing on is aluminum. This material is presently in widespread use and for the foreseeable future will continue to be in use for a long time. The particular material I will be covering in this video is aluminum 7075 T6. Aluminum 7075 T6 is an alloy with a higher strength than other aluminum alloys, while still retaining the lightweight factor. It can withstand stress in a variety of temperatures, which is ideal when flying at high and low altitudes. This material is very ductile, which allows parts of the aircraft to flex without fear of breaking. It also has a natural ability to form aluminum oxide. This layer of aluminum oxide prevents further corrosion and gives aluminum the ability to be in use for an extended period of time. This is why aluminum is the material of choice for large airplane manufacturers such as Boeing. Aluminum can be heat treated in one of two ways. However, I will be covering the annealing process, which is the most common way to heat treat this particular alloy. The material is first heated to a temperature of 775 degrees Fahrenheit. Once the material reaches this temperature, it is held here for 3 hours. It is then cooled at a rate of 50 degrees Fahrenheit per hour until it reaches a temperature of 500 degrees Fahrenheit. From here, it is air-cooled until the material reaches the temperature of the surrounding environment. This process yields a bainite microstructure. This microstructure is desired because it enhances the strength of the material without sacrificing its ductility. As previously mentioned, ductility is a necessity to allow parts of the aircraft to flex without breaking. In conclusion, airplanes will be forever a fundamental part of our society and our economy. However, as time progresses, new materials will be utilized and new types of aircraft will be constructed. This all begins with the materials used.